Hi guys, my name is Ernest and this is Ernest Sciences and Mathematics TV channel. I'd like to welcome all our members to my channel and also request them to kindly subscribe, engage us in the comment section and also ring that notification bell to be getting updates on our various uploads in mathematics and sciences. Our discussion today is going to be the concept of a force on a charged particle in an electric field. And of course, this is going to be adding up on the various discussion we have done on the concept of a charged electric field, and particularly the behavior of various aspects of an electric field, of course, a charged particle, and of course, the concept of an electric field. Now, in our discussion today, we're going to look at the interaction between a charged particle and an electric field, and this is going to be in form of this specific illustration which I've given on the left side of my board. Now, in this case, we are going to consider proton, which is going to be moving in this specific field. And of course, we're going to be trying to find the particular force which is going to be experienced by this particular proton. And perhaps we can treat it as a mechanism from a specific body from the classical mechanic aspect, which we are going to consider in trying to find its acceleration, velocity, kinetic energy, and particularly the force which is going to be applying in this particular case. Therefore, we're going to have this specific illustration whereby we're going to have a proton at this specific point which is positively charged. And in this case, we are going to expect these specific lines to be moving from this specific point, from the positive part, of course, a point of charge to the negative one. And therefore, we're going to see what is going to be the effect of this specific proton being exposed to this specific field. Now, in this case, if the proton is situated at this specific point, we're going to consider the distance between this positive and negative plate. And therefore, we can give this one in terms of x given as such. And if we consider this one, then therefore this particular proton is going to be moving in this specific direction. Therefore, if we try to consider this setup, we can just have this particular information for the distance between the positive and the negative plate given as x. So I can give this one in terms of 2.4 times 10 to negative 3 meters. So this is going to be a distance of separation between the positively charged plate and the negative one given as such. Now, if the electric field of the plate is 4.5, so we're going to have this one, which is a vector given in terms of 4.5 times 10 to power 3 newtons per coulomb. So I've discussed about the dimension of electric field from our last discussion. So I'm going to put a link of that specific video. So kindly, it's going to be in terms of a playlist. Open and check so that we can be at par with this specific concept of dimensions for this electric field. So given that the distance between this one and this one has been given and the electric field is being given using this specific magnitude, the proton is going to be starting from rest. Now, from mechanics, we have, of course, looked at an object which is going to start motion from rest, and therefore we're going to see that its specific velocity is going to be having a magnitude of 0, and therefore I'm just going to indicate that one given as such. So if we are given this information of a distance, electric field, and this specific proton starts from rest and moves towards this specific direction, therefore we're going to be requested to find the force which this specific proton is going to be experiencing in this electric field. And then second, we shall look at the acceleration of the proton. So I'm going to have this one just as this one. And then we shall also be requested, or we will be requested also to find the velocity which really the proton is going to be, of course, striking at the negative plate. So we shall have the velocity which is going to be final velocity. You can just give it in terms of these specific initials. And then we're going to look at the kinetic energy of the proton as it's going to strike at the negative plate. So we're going to find the kinetic energy in that specific aspect. So starting from the first one, we have been told that a proton moves from the positive plate to the negative plate parallel to each other at a distance of 2.4 times 10 negative 3 meters. And of course, if the electric field of this one, of the plate is equivalent to 4.5 times 10 negative 3 newtons per coulomb, if the proton starts at rest, we're going to be finding the force experienced by the proton In this case, we had mentioned that the magnitude of the force is equivalent to the product of the charge of that specific particle and the electric field. And therefore, having been given this specific particle as a proton, we had said that we can find of course, the charge of a proton and the electron, which are the smallest quantities which are going to form a unit of charge. And therefore, this is equivalent to 1.602 times 10 negative 19 coulombs. And therefore, we're going to use that specific, of course, amount for the charge. Therefore, we can do a substitution for this and find the amount of force, whereby we're going to just do it this way. So we're going to have this one as 1.602 times 10 negative 19 coulombs times the electric field has been given in terms of 4.5 times 10 to power 3 newtons per coulomb. So as we can see, these specific units are going to cancel out, and we're going to remain with the newtons. The force in terms of newtons, which is equivalent to 7.2 times 10 negative 16 newtons given as such. So kindly confirm from calculations if this specific figure is correct, and in case if it's you're finding a different one, kindly notify us in the comment section so that we can do rectification for that specific calculation. So secondly, we are required to find the acceleration of this. I can just give it in terms of A, which is going to be representing our acceleration for the sake of a space. So for us to find the acceleration of this proton, we're going to use Newton's second law of motion, which says that force is a product of a mass times acceleration. And in this particular case, the mass of the proton is also going to be a constant, whereby we're going to have it as 9.1 times 10 negative 31 kgs or kilograms given as such. So if we try to consider this specific aspect, then therefore we can make acceleration our subject of the formula, and then we're going to have it as a ratio between force and mass, which is equivalent to the force which we have obtained in our previous, of course, evaluation, which is 7.2 times 10 negative 16 newtons. So this is going to be divided by the mass, which is 9.1 times 10 negative 31 kilograms. And this is going to give us a value of 7.912 times 10 to power 14. Of course, we can just check on those specific dimensions which I'm going to give. And these are the two evaluations for the first two choices which we have taken for force and of course acceleration. Now we can do the third one, which is of course going to be a velocity. Now I'm going to consider to wrap this one for the sake of a space, so that we can use this one in finding for the two remaining evaluations. So we're going to find the velocity with which the proton strikes the negative plate. And in this particular case, given some of the, of course, equations of motion, of linear motion, and in this case, I'm going to consider finding velocity, final velocity. The velocity with which this specific proton strikes the negative plate is going to be a final velocity, which is given in terms of the square of the initial velocity, and of course the product of acceleration, twice the acceleration and the displacement given as such. And of course, we're going to see that I've mentioned from our previous statement that this one starts from a rest, which is basically going to be given in terms of a u. So therefore, we're going to consider this specific u to be equivalent to 0. So therefore, this is going to be the square of that one equivalent to 2as given as such. So basically, v is equivalent to a positive value of the root of 2as given as such. So having found the amount of, or the quantity for acceleration, we're going to consider this one, and the displacement we have been given from this one, the positive and negative plate, as a quantity over x. So for us, we are going to do a direct substitution for that one and find the positive root of 2 times. So the value for acceleration for us was 7.912 times 10 to power 14. And then we had this one times 2.4 times 10 and negative 3 meters given as such. So in this case, we're going to find the root of that one. And from my end, I'm finding this one velocity as 1.728 times 10 to power 6 meters per second given as such. So this is going to be the velocity with which this specific proton is going to strike the negative plate. And lastly, we're going to look at the last part of it, which basically requires us to find the kinetic energy with which this is specific, of course, a proton is going to strike the negative plate. Now, from classical mechanics, we're going to find kinetic energy as half the product of mass and the square of velocity. And from that one, we can evaluate it by also doing a direct substitution, which basically is going to be given as half times the mass of this specific proton is going to be given in terms of negative 31 times the square of velocity, which of course we have done an evaluation from our last discussion. So this is going to be given in terms of the velocity which we have given, which is 1.728 times 10 to power 6 meters per second, given as such. So kindly do an evaluation and find the kinetic energy in terms of joules, as we are going to see later. And you can give our answer in the comment section so that we can see whether we are going to have of course, a common figure for our evaluation. Now, in this particular case, it is going to be how we can evaluate the force on a charged particle, apart from other aspects of acceleration, velocity, and kinetic energy, which we are going to consider due to the interaction between a charged particle and the electric field, which I've just given using this specific example. So kindly check our description boxes for various links of other videos, and also subscribe and engage us in the comment section for other related content. So that is it for now, guys. By God bless. We'll catch us in our next video.